Today let us look at a concept called Euclid's division lemma. But what is Euclid's division lemma? Let us do a simple division. Let us take 342 and divide it by 7. We get a remainder that is less than the divisor, so the division cannot continue. Since 6 is less than 7, the division cannot progress. Now recall that 342 is called the dividend, 7 is called the divisor, 48 is called the quotient, and 6 is called the remainder. Now we know that there is a relationship between these four. We know that dividend is equal to divisor times quotient plus remainder. And of course the remainder has to be less than the divisor. If it wasn't less than the divisor, then the division would continue. Now let us shorten these words and write them as A is equal to B times Q plus R, where Q is the quotient and R is the remainder. And R has to be less than B. Now A is equal to BQ plus R, where R is greater than or equal to 0 and less than B, is known as Euclid's division lemma. Now this concept has application in finding the HCF or highest common factor of two numbers. How? So we have the dividend and the divisor. The bigger number becomes the dividend or A and the smaller numbers becomes the divisor or B. We do the division and figure out Q and R. And we repeat the process with B and R. Like this. And in the process we would find new B and new R and continue this till we find the remainder or R as 0. This does not make any sense. Let us see this with an example. So let us look at the first problem. Use Euclid's division algorithm to find the HCF of 608 and 32. Let us see how to apply this. So let us write Euclid's division algorithm as A is equal to BQ plus R. Now let us take the larger number as A and the smaller number as B. So we have to divide 608 by 32. Let us quickly do that. So we find that 608 is equal to 32 times 19 plus 0. Wow, we have found the remainder 0 in the first iteration. So B or 32 is the HCF of 608 and 32. If you get confused between 19 and 32, which one of these is the HCF, then recall that the HCF, highest common factor, this factor needs to divide both the numbers 608 and 32. Now here, while 19 is a factor of 608, it does not divide 32. So 19 cannot be the HCF. So by elimination, you can figure out that 32 is the HCF here. Let us look at another problem. Use Euclid's division algorithm to find the HCF of 196 and 38,820. So let us write the algorithm once again and take the larger number as A and the smaller number as B. So we are going to divide 38,820 by 196. Let us quickly do that. We see that Q is equal to 198 and R is equal to 12. Now note that R is not 0 yet. So let us choose our B and R and do the second iteration. So we write A is equal to BQ plus R once again, but this time A is 196 and B is equal to 12. So we are going to divide 196 by 12. Let us quickly do that. and we see that Q is equal to 16 and R is equal to 4. Once again, our remainder or R is not equal to 0. So let us continue for the second iteration. So 12 becomes the new A and 4 becomes the new B. Now 12 is equal to 4Q plus R. We know that it is equal to 4 times 3. So this time the remainder is 0. Now 4 here is the HCF of 196 and 38,820. Now it is interesting to note that 4 is the HCF of 196 and 38,820. It is also the HCF of 12 and 196. And 4 is also the HCF of 4 and 12. Let us look at another problem. A sweet seller has 420 Kaju burfis and 130 Badam burfis. She wants to stack them in such a way that each stack has the same number and they take up the least area of the tray. What is the number that can be placed in each stack for this purpose? Let us take 2 stacks. Now we want to get the same number in each stack. So we could rearrange these burfis. Let us change the number in one of the stacks. Once again, we can rearrange the burfis in the other stack for all the stacks to have the same number of burfis. Now note that we are taking a common factor to divide them into stacks. But for them to take up the least area of the tray, we would need to find the highest such common factor or HCF. So let us write our algorithm and take the larger number as A and the smaller number as B. So we are going to divide 420 by 130. We get Q as 3 and remainder as 30. Now since our remainder is non-zero, let us take the B and R and put them as A and B in the next iteration. Now let us divide 130 by 30. We get remainder 10. Now let us take 30 and 10 as the new A and B. And we see that 30 is equal to 10 times 3. The remainder becomes 0. So B or 10 is the highest common factor here. So we are going to have 10 burfis in each stack.